This video is going to be about Lewis dot structures, as well as talking about oxidation numbers. So, first thing we're going to talk about is valence electrons. And why they're important. Okay, valence electrons are the outer shell where bonding takes place. Okay, electrons are traded. Valence electrons are traded or shared. So as we go down, group 1 has 1 valence electron. Group 2 has 2 valence electrons. Now we skip the transition metals and we go to group 13. They have 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5 valence electrons. Group 16, group 17, these guys have 6 valence electrons, these guys have 7 valence electrons, and then we got group 18, which has 8 valence electrons. Now, in order for an element to be happy, it needs 8 valence electrons, okay? That's the important thing. Now, let's talk quickly about oxidation numbers since I have this guy pulled up. Oxidation numbers are the number oxidation numbers are the numbers given to an element once it has given or taken valence electrons. Okay, so that's usually what occurs in bonding. Now, group 18 is going to have 0 valence electrons. Group 17 is going to be, the oxidation number is -1. Group 16 is -2. Group 15 is -3. Group 14 is plus or -4. That's because carbon, silicon, and germanium can either gain or lose 4 electrons to become stable. Group 13 is +3. Group 2 is +2, and then group 1 is +1. So that means that whenever it's bonding, every element in group 1, 2, and 3 will have their respective oxidation numbers. That's because they're losing those electrons. And so the way the formula goes is if they're in a neutral atom and they're going to lose, so minus, let's say 2 electrons. So that would give us, if they're going to lose 2 valence electrons to something in group 2 like calcium, a minus times a minus equals a positive. So it's Ca2+. Okay, that's the way it goes. So that's valence electrons and oxidation numbers. So let's look at a couple of examples right quick. Okay, go ahead and pause the video and copy these down. Alright, now that you're back with me. Cs is going to be a +1 because that's what we find on the periodic table. P, 3-, S, 2-. Now, Fe is a transition metal. Whenever you have a transition metal, the other thing you have to absolutely positively can't get away with without having is you have to have a charge on it. So these Roman numerals right here. So whatever the Roman numeral is, that's what the answer is going to be. So if it was 3, it would be 3. 4, 4. In this case, it's Fe2+. Ca is 2+. Mg, 2+. Al, 3+. O, 2-, and F-. Now, Kr is 0. We don't put anything. It doesn't have an oxidation number. Okay. Last part that I'm going to talk about on this notes are Lewis dot structures. Okay, so Lewis dot structures. Now, this is really, really simple. Okay, I'm going to use these examples that we have. Alright, so what we do for Lewis dot structures, we have the element symbol with however many valence electrons there are. So in this case, for Cs, 1 valence electron, 1 dot. That's it. Alright, so for phosphorus, it's 5 valence electrons. So we go 1, 2, 3, 4, 5. Now I did that wrong. Watch for sulfur. It has 6 valence electrons. We start at the top, so 1. We go clockwise. 2, 3, 4, 5, 6. And so we have 2 valence electrons right here that are open for bonding. This is the reason why S has a -2 charge, because it needs to accept 2 valence electrons in order to be happy. Same thing for phosphorus. It needs to accept 3 valence electrons to be happy, because it wants to have this right here. If you look at krypton, it's 1, 2, 3, 4, 5, 6, 7, 8. It wants 8 valence electrons surrounding it. So with phosphorus, it only has 3 to be happy. With cesium, this is the reason why it's a +1 charge. It needs to lose this 1 valence electron in order to be happy. It goes down a level to the 8. That's the reason why it bonds. Now Fe, same deal. Whatever this number is, that's its charge. So 1, 2. That's it. Ca, same deal. 1, 2. Mg, 1, 2. Aluminum, 1, 2, 3. Oxygen, 1, 2, 3, 4, 5, 6. And fluorine, 1, 2, 3, 4, 5, 6, 7. Hopefully that helped. If it didn't, let me know. Peace.